Hi everybody and welcome to a new video in the Generating Melodies with LSTM Networks series. Last time, guys, we finished pre-processing and specifically we built a function that will enable us to generate the different training sequences that we want to feed into our network for training the generative, this like model for melody generation, right? So before we move on to the topic, today's topic, which is basically building the network and training it, I want to be sure that you guys have everything in place for training the network. So far, we've used some, for pre-processing, some like dummy data. So specifically, oh yeah, that's not that. So if we go here, so this is our folk song dataset. So far we've been using this test folder that only has 12 songs. Obviously, we don't want to train our models on this. So what you want to do is to pre-process some other songs that are in this dataset. What I'll be doing today is pre-processing the ERK collection, which is all the songs like in this collection here in this folder, and this amounts to something like more than 1,500 songs, which should be okay with for our purposes. But then if you want to have like even more data, you can just use this Deutsch dataset over here directly. So you would just like do this, and then you're just pre-processing like all the songs in the dataset there. Okay, so all of this to say that I run pre-processing with ERK, and I got a few things here out. So the file dataset, the single file dataset where we have all the different songs in the ERK collection slammed together. And then we also have like our mapping.json file where we have like all the different symbols mapped to integers. And overall we have 38 symbols, which is our vocabulary size, which we need to remember because we'll use that. Okay, so now let's get into today's job, which is training and creating a network, an LSTM network for generating these melodies. Okay, so we need to create a new Python file, which I'll call train.py. So now, today we're going to be building two functions. So one we'll call just train, and this is going to be a high-level function that will do all the steps that we need in order to train the network. So let's just outline these things and then go through them one by one. So the first thing that we want to do is just generate the sequences, the training sequences. And for this, we're going to be using the function that we built in the previous video. Okay, so once we have that, the next step is to actually, so you guys should excuse me here because I have size 16. Let me just like go with size 23 because yeah, this is easier for you to follow, guys. Sorry about that. So after we generate the training sequences, the next step is to build the network. So we want actually to build the model. And as you'll see, we'll create another function that will only be responsible for generating and compiling the model. Okay, so once we have the model, we want to train the model. And finally, we want to save the model so that we can reuse it, call it back, and yeah, do all the inference that we want on that. Okay, so this build network, train network, and save model is like the usual way you actually create a model with Tensorflow and Keras. Okay. So let's start from this generating the training sequences. As I said, we want to use this function here in the preprocess file. So I think it's this one, generating training sequences. So obviously we need to import that. So let me import this, and I'll say from preprocess import this function. And we also know that this function accepts the sequence length as an argument, and we have a constant over here in the preprocess file. So we want to import that as well in order to avoid having redundancies, right? So let's go back to train. So we'll import this generate training sequences, and we'll also import this constant here. So here we go, sequence length. Okay, good. Okay, so we know that the output of the generate training sequences function is the inputs and the training and the target sequences, right? So these are all the sequences with the x's and y's that we need to pass to the model for training. Okay, so now let me invoke this. Oops, sorry about that. Invoking that function, and I can pass in the sequence length over here. Okay, good. So this is the first step. Now the second step is to build the network. So we want to build the graph with all like the LSTM layers and things like that. Okay, so how do we do that? Well, we, as I said, are going to have a custom function for that, which we can call build a model. Okay, so this function is going to accept a number of parameters. So the first one is output units. So these are like basically how many neurons we need in the output layer. Then we are going to have a bunch of other parameters. So the loss function, for example. Then we're also going to have the learning rate. And for all of these things, so we can just create constants up here. So we could say output units, and this is going to be equal to the number of symbols or the vocabulary size in our dataset, which is equal to 38. So 37 plus, yeah, this initial element that's indexed to 0. Okay, so let's go back here. So this is 38. Then we have the loss function, and this is the error function that we'll be using for training. And we are going to use sparse categorical cross entropy. So let me just see if this is spelled correctly. Sparse categorical cross entropy. Yeah, seems fine. And then the learning rate. So the learning rate is going to be equal to 0.001. And yeah, I think I forgot another parameter here, which is the num units. So this is equal to the number of units of neurons that we have in the internal layers of the network. So let me create a constant here. So I'll call it num units, and this is going to be a list, and this is because we may have more than one internal layer. In our case, I'm going to be building a network with only one LSTM layer, which has 256 different neurons. But I'll tell you also how to build a network like with more than that. So you may want to have like something like this, for example. So 2 layers. And in order to keep track of all the different neurons that we want for each layer, we are going to be using a list like this. Okay. Yeah, this seems fine. So now, obviously, what we want to do here is to get these guys and pass it as arguments to this train function as well. But we are going to default them directly to these constants. So this num units is going to be equal to this guy here, then loss is going to be equal to loss, and this learning rate is going to be equal to learning rate. Okay, looks good. Okay, so obviously we haven't built this build model function yet, so let's do that. Okay, so I'll define a new function here, which I'll call build model. And this function takes all of these arguments. Okay, so now there are a couple of things that we should do here. So thing number one is just create the model architecture. And the second thing is to actually compile model. So we'll create the model and then we'll compile it. And this is something that you always do in Keras. Now, there are a couple of ways you can create models and architectures in with Keras. So one, which is like the one that probably many of you would be familiar with, is called using like a sequential approach, but we're not using that. I want to use for the first time in my tutorials the other approach, which is a little bit more flexible. It's called the functional API approach. So we are using the functional API, Keras API, for building this model. The great thing about this approach is that you can build very, very complex architectures that have nonlinear topologies. This is not going to be the case in today's video, but still, I think like it's important for you to know how to build a model in Keras with the functional API approach, because when you'll be working on your models, and if these are like very difficult, very complex models, you want to use this flexible approach. Okay, so now another caveat here is that I'm not going to explain the ins and outs of LSTM networks and all of these things because I've already done that. So you should see a video over here where you'll have explanation of like what a recurrent neural network or like an LSTM network more in particular is, and you can check that out if you want to know everything about like the background and the theoretical stuff about LSTM. So I'm just gonna give you like the code here. Okay, cool. Okay, so the first thing that we want to build here is the input layer. So for doing that, obviously we're going to need to use the Keras API. So we haven't imported that yet, so I'm going to import Tensorflow.Keras as Keras. Okay, so now if you don't have a Tensorflow installed, you can just, I'll show you that. So you can fire up your terminal, do a pip install Tensorflow, and this should be okay for that. Now, if you want to build the GPU version, have the GPU version of TensorFlow, that is gonna like take you a little bit more work for doing that. But then again, you can easily go check out the TensorFlow documentation, and like it's very well documented. You can figure that out by yourself. Okay, so now we're back to this input here. So the input layer, we want Keras.layers.input, and what we want to pass in here is a shape. So this is going to be the shape of the data that we are passing in to the network. Now we are going to have to put in a couple of values here. So the first value is none, and the second one is equal to output units. So let me explain what this is. So this is the first dimension, and basically it tells us how many sequences, how many sample time steps we have in the sequence that we are passing to the model, right? Because this is going to be a sequence and with a bunch of time steps in it. And so if we say none here, it basically enables us to have as many time steps as we want in the network. And this is great because with this approach, we can then generate melodies of like whatever like length we want, and we can pass into the network sequences or melodies which have like whatever like length we want. So this is done just to have like this variability and not constraining the training and generation sides of things here. Okay, so this second value output unit basically tells us so how many elements we have in for each time step. So if you guys remember from the previous video, so we've one hot encoded these sequences, which basically means that each time step in the sequence is gonna be a one hot encoded array where we have as many items as the vocabulary size, and it turns out that we want to have like the output units, the number of output units to be the same as the vocabulary size. So this output units is basically like our vocabulary size, which in our case, we've already seen here, is going to be equal to 38. Okay, speaking of which, we can use, I just like for a second that I forgot like to pass, like to default this output units value with this output units constant, but I've done that. Okay, looks good. So this is the input unit. Now we want to create, we want to add another node to our graph, to our model. So for doing that, we should pass a new layer to this input object here. So how can we do that? Well, we take a new layer and we want an LSTM layer over here, and we need to pass the number of units that we want in here, and we know that is equal to num units at index 0, and we use this syntax here, okay, to say that we are calling this layer on this object, on this input object. So this syntax, what it does, and the way you can visualize it, is that whenever you do this action, you are drawing an arrow from, in this case, from input to this LSTM layer. So we are passing the input to this LSTM layer. So this is the way you add nodes in the functional API with Keras. Okay, so now we want to add a regularization, a dropout layer. So we'll do something like this, and we'll say 0.2 over here, and here we'll just pass this object X object over here. And so here we're adding another node, which is a dropout layer to the model. Now, if you're not familiar with dropout, this is a technique that we use to avoid overfitting. Again, I'm not going to get into the details here. I have a quite in-depth video about techniques you can use to combat overfitting. So you should find it over here. If you're interested, go check that out. Okay, so the next step here, if we are dealing just with a simple LSTM with only one layer, is to build the output layer. Okay, so this is going to be a softmax classifier. So for doing that, we'll do Keras layers. We'll have a dense layer here, and we need to specify the number of units that we want in this dense layer, this output layer, and obviously this is equal to the output units. And then we need to specify the activation function that we want to use, and in our case is going to be a softmax function. Okay, so here we need to call this dense layer once again on this X object. Okay, so now that we have our input and output layers in place, so what we should do is to actually build the model. And for doing that, we'll do a keras.model, and we can pass in the input and the output. That's it. So this is like very, very nice and simple. And this way you can build graphs or models that are as complex as you really want. Good. Okay, so the next step now is to actually compile the model. So how do we do that? Well, this is quite straightforward because Keras comes with a method that's called compile. And here we should pass a few parameters in. So first of all, we want to specify which loss function, error function to use. And obviously we'll just pass in this loss function here, which in our case is going to be sparse categorical cross entropy. Then we need to pass the let me just go here, optimizer. And so this is the algorithm that we're going to use for optimizing and for training the network. And we're going to be using Adam for this. And so we can do a keras.optimizers.adam. And here we can specify the learning rate. And so I'll put in a LR, which is equal to our learning rate argument over here. Now this is getting like a little bit too busy, so I'll just go to new lines. And finally here we can specify the metrics that we want to track. And so we'll just track accuracy here. Okay, so this is good. So now we've compiled the model. So before returning it, we can just print a summary of the model. What this will do, it'll print some information about all the layers of the model with like the relative shape, like for the inputs and outputs, as well as for all the parameters that we have in the model itself. So it's a nice way of just like having a visual feedback of the model that you've just built. Okay, so now I'm gonna return the model. Okay, so now that we are done with this build model function, we can go back to our train function, right? So here we've built the model. Now it's time to train it. So training, once again, is very simple in Keras because we can invoke the fit function. And here for training, we're going to pass in the inputs, so our x's, and the targets, which are our y's. And then we want to specify a couple of other parameters, so the epochs. And I'm going to create a constant with the epochs that we want to train this model for. And we also can specify the batch size. And once again, we're going to create a constant over here, batch size. So now the epochs is over here, and we. So I've tried out like a few different kind of like training this model like with a bunch of different epochs. What usually worked for me was like something between I'd say like from 40 to 100, something like that. But yeah, let's put just like 50. So this is a hyperparameter you can play around with. Now, once again, if you don't know what epochs are, just like go and check out my series on deep learning for audio. There I give you like a very in-depth introduction to all things deep learning, both like theoretical and implementation wise. So you should have the playlist to that series over here. Okay. Now, the batch size is yet another parameter, and we'll put this equal to 64. In a nutshell, the batch size is the amount of samples that the network is going to see before running back propagation. Okay, so this way we have trained the model. So now, the last thing that remains to do is to actually save the model, because we don't want to start every time from scratch. And as you'll see, it's going to take quite some time to train this model. So you want to store it so that you can then load it. And we're going to be loading this from a class that probably will call something like melody generation or melody generator or something like that. And so we need to store the model itself. So fortunately for us, Keras gives us this amazing save method, and saving a model is as simple as passing in a path where we want to save the model. Okay, so here we can have yet another constant, which we can call save model path. And I want to save the model in the working directory, and the file name is going to be model.h5. Now, if you're wondering about this .h5, well, this is the format that Keras uses for saving Keras TensorFlow models. Okay, so I think like we should be done here, because we have everything that we did like for training and for building the model. So now we should just see if this works. Okay, so for doing that, we'll do a if name is equal to main, then we'll just run train over here. Okay, so I'll run this and see what happens. Okay, so the script is loading TensorFlow. Now let's see if we get any error. Yes, we got an error. Okay, so I just figured out what this error was, and even though I double checked this, I didn't see this spelling error. So this sparse categorical cross-entropy, but here we have a C instead of a G. So let's change that. Okay, good. Okay, I'm gonna rerun this, and fingers crossed this is gonna work this time. And once again, we have the GPU running. Okay, yeah, it seems to be working, but I want to draw your attention over here, because here we have like the summary that I was talking about, right? So here, as you can see, we have this LSTM layer, and here we have the shape like of the input, and here we have the number of parameters, and here we have like the total number of parameters in our network. Okay, so now it's gonna, as you can see, like it's training down here, and we have like the accuracy over here. So it's going to take like quite some time. So I'm probably going to just pause the video and get back once we've gone through like all the epochs and this is done. But before I do that, you may be wondering, but Valerio, why aren't you using like training data as well as testing data? So why didn't you split your data set in train and validation, or train and test? The thing is that of course we could have done that, but when you are training a model that should like generate music like this, you're not really that interested in like saying how the model does on unseen data. All you're really interested in is that you get something that works. And so for that reason, unless you're really keen on doing like evaluation on the model and understanding like whether like it generalizes well and all of those things, I mean, it's also fine if you just use all of your data set for training purposes. For sure, that's really good if you have a very limited data set, which is usually the case when you're dealing with like generative music and symbolic music. But of course, like the right way to do it would be to split the your data set into training and then like test if you want to do like some in-depth analysis and evaluation of the model. But I'm not going to do that, so you are free to do that, but I'm going to go for the shorter route here. Good, so I'll see you in a second once the training is finished. Here I'm back, and as you can see, the training process has ended. So, and here in our working folder, we have this model.h5 file that stores all the information about our model. Okay, so this is all for today, and this is basically the basis upon which we're going to build our generative model class, which is going to basically use this train model for generating music. This is going to be the topic for our next video, so we'll understand how to actually generate melodies, and then how to sample all the notes and all the symbols like for this new melodies. Good. So I hope you've enjoyed this video. If that's the case, as always, leave a like. And if you haven't subscribed yet, please do. And if you have any questions, as is usually the case, just write them in the comment section below. And I hope I'll see you next time. Cheers.